Good morning, this is Mrs. Yule. I am going to do the very first video for our third packet, and we're going to be looking at perimeter and area. I'd like to go over perimeter and area, although I know most of you understand perimeter and area and know how to find it. I'm just going to give you a refresher on this. So when I think about perimeter, I always tell people it's how far I would travel if I were a tiny ant and I was crawling all the way around the edges of an object. So really all you have to do is add up all the sides. When I look at the definition for perimeter, it's the distance around the outside of a shape calculated by adding the shapes together, pretty much what we just said. And when I find the perimeter, I'm going to find the sum. Sum is a fancy word for saying add them all up in math. If they give you the measurements, it's really easy to do. The thing I don't want you to forget is units. So when I talk about perimeter and area, I always expect you to put units. For perimeter, the units are just plain units like centimeters, meters, feet, inches. So here I add up 4, 8, 4, 8, and I get 24 centimeters. Here, 4 centimeters plus 8 centimeters plus 6 centimeters is 18 centimeters. And here I have 19 centimeters. So easy enough if they give me all of the lengths. I don't have to do very much work at all. Usually they give me irregular shapes, so I have to go ahead and figure out what some of the dimensions are. And this is always the challenge. If I know this is 8 centimeters, they didn't tell me what this little piece was right here. But I know that I can find it because if this is 2 and this is 2, 8 minus 2 gives me 4 centimeters right there. And then I have to find this length right here, which is going to be 2 centimeters. This one would be 4, add them up all together, and I get 28 centimeters. Notice again, it's just plain units, not units squared, not units cubed, just centimeters. I can also figure out perimeters of regular polygons. A polygon is a closed figure. Regular means all of them have the same side. So if I have 3 sides, I multiply the side length times 3, and so on down the line. If I have 7 sides, I multiply it by 7. Area is a little bit harder. Let me move myself. When you find the area, you have to remember that it's units squared because we'll be multiplying, and inches times inches is inches squared, meters times meters is meters squared. I think of area as the stuff inside of a two-dimensional figure. So when I talk about area, I am talking about two-dimensional objects. The definition here says it's a size a surface takes up. It is measured in square units. Easy enough to do if they have the shape on a grid. And I see people struggle with this and I'm not sure why. So if you're on an achievement test or some kind of test where they've got a figure laid out on a grid like this, all they really want you to do is count up the squares. A lot of times the squares are partially filled in, so you have to estimate whether it's a half or a quarter. But remember, if you have a figure and it is on grid paper, you simply count up the little squares that are filled up. Don't leave it blank. If I don't have it on grid paper, I do need to do some work. So the formula for the area of a circle is pi r squared. For a squared, it's side squared. Rectangle and parallelogram, here are the formulas. We gave you a formula sheet to use too, and I expect you to pull it out and use it as you're finding different areas. So let's look at that for a second. The sheet that we gave you starts out with just some measurement conversions. You should keep that handy. You may need them at some point. And then here are the two-dimensional figures. And again, you will have the formulas. So I have a rectangle, a parallelogram. On my sheet, you can see I drew a red triangle. For somehow on the printer, the triangle did not print out. You need to draw the triangle there. I know that the formula for triangle is 1/2 base times height. I think that's very interesting. Then for area of a circle, we have pi r squared. There are some more parts to the shape, to the sheet I'm just going to cover for a second. We do give you volumes and surface area, and we will be covering these in further videos, so make sure that you know that they're on that sheet. Another formula is Pythagorean, distance formula, midpoint formula. This is a trig formula we'll go over in the trig section, and then slope, change in y's over the change in x's, and every single one of you should know how to find slope of a line. So I want to look at the midpoint formula. This seems really easy, and then sometimes we get to it and it's not so easy. I had to make sure I erase my board. So if I have a line segment AB, so this means I am going from point A to point B, I can find it, the midpoint, by finding the average of the x's and then finding the average of the y's. So this notation right here, AB with a line over it, means I have a line segment called AB, and I want to find the midpoint of that line. So add up the x's, divide by 2, add up the y's, divide by 2. Sounds pretty easy. So let's look at it. This first one asks us to find the midpoint. So I have RS. They give me the coordinates for R. It's 1, -3. S is 4, 2. They want me to find the coordinates of the midpoint. Easy enough. For B, they give me that I have a line segment JK. The midpoint is 2, 1. So this time they gave me the midpoint. They give me one endpoint. They say J is 1, 4. Find the coordinates for K. So we have to work backwards to find that one. So let's go ahead and do these on the whiteboard. Let me go to a new share. It's always fun to change back and forth on these. Okay, so if you didn't have time to write down the problem, go back a little bit, pause me while you write down the problem, and then catch back up. So for this very first one, I have line segment RS, and I know that R has the coordinates 1, -3, and S has the coordinates 4, 2, and they want me to find the midpoint. So let's sketch this one for a second. Here's +1, 2, 3, 4. Here's -1, -2, -3. Here's +1, 2, 3. So 1 and -3, I go over to 1, I go down 3. This is my point R, and I could write this as 1, -3. And then S is my point 4, 2. Here's 4, go up 2. So this is point S, and it is 4, 2. I can connect them, and I need to find M. Remember, M is equal to x1 plus x2 divided by 2. That's my x coordinate of my midpoint. And the y coordinate is going to be y1 plus y2 divided by 2. So here's x1, y1, here's x2, y2. So the midpoint is going to be 1 plus 4. I'm adding up the two x's divided by 2, comma, -3 plus 2. I'm adding up the y's, -3 plus 2 divided by 2. 1 plus 4 is 5. So this is going to be 5/2 here. -3 plus 2 is -1. So my midpoint is the point 5/2, -1/2. So 5/2 is about 2.5. So we could say that this is the midpoint, which is going to be 5/2, -1/2. For the next example, if I have line segment JK, and J is going to be the point 1, 4, and the midpoint is going to be 2, 1. They want me to find K. So they are asking me to find x2, y2. So I know that this is the x value of my midpoint, this is the y value. So I can say here is x1, here is y1. The formula, remember, is x1 plus x2 divided by 2 has to equal this value of the midpoint. And then I'm going to say that y1 plus y2 divided by 2 is equal to the y value of the midpoint. I know what x1 is. I'm going to plug it in. So I have 1 plus x2 divided by 2 is equal to 2. Here I know what y1 is. I'm going to plug that in. I get 4 plus y2 divided by 2 is equal to 1. I want to get rid of this 2, so I'm going to multiply both sides by 2. And I'm going to get 1 plus x squared is equal to 4. Subtract 1, and I get x squared. x2 is equal to 4. x2 is equal to 3. Here, I'm going to multiply both sides by 2, and I get 4 plus y2 is equal to 2. Subtract 4, and I get y2 is negative 2. So I'm saying that my point K is going to be 3, negative 2. How'd that go for you? So go ahead and write that all down. If you need to stop and pause here for a minute, do so, and then come back to the video. I am going to go back to sharing my screen. All right, so here was the problem, and I do have the answers on the next slide. Let's see how we did for this one. And here they have the perfect graphs made for this. So notice that they did get 5 halves, negative 1 halves, and they did get 3, negative 2. And here are the graphs for those. So we did it right. I'm always happy when I do it right. You never know when you go up to the whiteboard. Okay. So the next thing we want to talk about is they do not always give you the side length. Sometimes you have to use the distance formula to figure out the side length of a shape, especially if it's one that they've already plotted for you on an XY coordinate plane. So when I was in high school, I always forgot the distance formula, and I couldn't remember it. And so finally what I figured out is that you could derive it yourself if you know the Pythagorean theorem. So I'm going to show you how to do that. I'm also going to give you the distance formula. If you have a memory that remembers formulas really easily, you won't have any problem. But if you ever forget it, just know you can figure it out yourself. And I actually like that better. I like being able to derive formulas rather than memorizing. So Pythagorean theorem says if I have a right triangle, this is true only in a right triangle. What I know is that c squared is equal to a squared plus b squared. C is the hypotenuse, A and B are what we call legs. So you have to have the right side out here. This is always the hypotenuse, the one that is opposite the right angle. So I am going to derive the Pythagorean theorem with you. So you can pause me if I go too fast. And hopefully this will help you so you never have to figure out how to do this. And I'm going to be going back to the whiteboard here. So what often happens when I'm trying to figure out the length of something and let me find my pen I put down over here. So say I have a line segment. Let me redo my line since it went really crazy. Okay. And I'm just going to make it be all in the first coordinate. It can be anywhere and it works out the same thing. So here I have point A and I have point B. So I am going to say to you, find the length of line segment AB. And we're going to see if we can come up with a formula for that. If I talk about generalities, I know that this point has an x and a y coordinate. So I'm going to call this point x1, y1. This also has an x and a y, and I am going to call this one x2, y2. And I want to find the length of that. I know how to find the midpoint, which is not very helpful right now. But I want to see, can I find the length? The first thing you're going to do is you are going to make a right triangle. So I am going to draw a line here that is parallel to the x-axis. And I'm going to have a point here, which I'm going to call C. And then I've drawn another line, this time it's parallel to my y-axis, and it goes from B down to here. These two lines are intersecting. They could go on, but really C is the point where they cross each other. So I have just made a right triangle. And now this side is going to be my C because it is opposite the right angle. This will be side A because it's opposite angle A, and this will be side B. Now, I know for sure, using the Pythagorean theorem, that a squared plus b squared is equal to c squared. And I know right now you're saying, how does that possibly help me do anything? So we need to be able to write A in terms of my y's and side B in terms of my x's. This point right here is going to have the same x coordinate as A. So this point is actually going to be x. It is going to have, it's going to have the same x value as point B, so it will be x2. And my y value is the same as point A, so it is going to be y1. And I don't know if I wrote it wrong or I said it wrong. This one is x1, y1, x2, y2. So this point right here is the same as this x, the x value, and the y value is the same as this y value because of the way I constructed it. So I could say that side A is the difference between y2 and y1. So this is going to be y2 minus y1. That's what A is equal to. And B is going to be the difference in the x's. So this is x2 minus x1. So if I look at this, I'm going to say that y2 minus y1 squared plus x2 minus x1 squared is going to equal c squared. Remember, I want the distance between these two, so I don't want the squared. In order to get rid of the square root, the square, I am going to square root both sides. So what I have is c, or the distance, is equal to the square root of, and I'm going to put the x's first because that's usually how we write it, x2 minus x1 squared plus y2 minus y1 squared. Now, hopefully that helps. If this made absolutely no sense to you, it is okay. I just wanted to show you how to derive it. It's not a formula that we made up or it comes from a mysterious place. We could actually figure out how to find it. Let me go back to sharing my screen. So here we derived it, and if you're in Math 3, I do expect you to know how to do it. And it would be a really fair question on a test, although we're not going to have them this semester. So here is the formula. x2 minus x1 squared plus y2 minus y1 squared, and here is the square root. So again, notice this side, they're saying x2 minus x1, y2 minus y1. Oops, let me move myself somehow so you can see this whole thing. There you go. So this is the difference in the y's, this is the difference in the x, and that's so they get the y2 minus y1, x2 minus x1. So distance formula is not a mystery. It comes right out of the Pythagorean theorem. If I went to you, oh, this is really super fun. Okay, so your school is 4 miles east and 1 mile south of your apartment. Recycling center, where your class is going on a field trip, is 2 miles east and 3 miles north of your apartment. Estimate the difference between the recycling center and your school. So what I want you to do is go ahead and write down the given information. Pause the tape right now, write down the given information, and then come back to where I'm going to be doing this on the whiteboard right now. But make sure you have the information written down so you don't have to ask me what we're doing. Well, because I won't answer you, I'm on the tape. So let me erase this. And these problems are really interesting. So I am going to start this by making an XY grid. And my school is right here at the origin. If you've never done this kind of thing before, it's going to seem very weird to you, but I can put a compass on a coordinate grid, and by convention, this is always north, this is south, this is east, and this is west. So we're starting at our school, and all our directions are given from our school. If I know and I forget which one is which, let me look back at the problem just a second. Okay, so the school is 4 miles east and 1 mile south. I couldn't remember which was which. So I should have done a better job writing mine down too. Okay. So, oops, wrong thing. Okay, so I am going to go 4 miles east. And then I am going to be 1 mile south. So here's 1, 2, 3, 4. So if I move 4 units to the east and 1 mile south, I'm moving down. So this is -1. So here is my point right now, and I am 4, -1. For the other one, I am going to be 2 miles east, and I am going to be 3 miles north. So I need to plot that point. Here's 2 miles east, 1, 2, I went east, and now I'm going to go north, 1, 2, 3. So here's my point, 2, 3. Now I want to know how far apart they are. And I'm going to use the distance formula here. It doesn't matter which one is x1, y1, it works out either way. So let's call this one x1, y1, x2, y2. Then the distance is equal to the square root of the difference in the x's squared plus the difference of the y's squared. So the distance is going to equal the square root of 3 x's first, 2 minus 4 squared plus, I started here, I'm going to start here this time, again 3 minus -1 squared. 2 minus 4 is -2. So I have -2 squared plus minus a negative is a plus. So 3 minus -1 is 4. This will be 4 squared. So distance, which I should have put on all of these, is equal to the square root of, you need to be really careful, and I've said this to you before if you've had me, whenever I square a negative number, I get a positive number. If you were to just put that in your calculator as -2 squared and you had a TI, you would get -4. So you need to make sure that you know when you square a number, it is always positive. 2 times 2 is 4. 4 times 4 is 16. So the distance is the square root of 20. If you are in math 3, actually my math 2 also, I'd want you to simplify this. 20 I can write as 4 times 5. So the square root of 4 times the square root of 5. I would want you to write the distance as 2 square roots of 5. If you want to do it on your calculator then and just approximate it for me, you will get that it's about 4.5 miles. So I have 2 answers. I have an exact answer, and then I have approximation of the answer. So we're saying they are about 4.5 miles apart. So let's go back to the smartboards. And let me see if I put that in. I did. So they are about 4.5 miles apart. And here's their perfect graph. It is really interesting when you get to graph it on a grid and graph paper versus on a whiteboard. So that's just the use of a distance formula. And sometimes you're going to be finding out the distance of sides, which is why I gave you this. You do need to find side lengths. Last thing we're going to look at is circumference and area of a circle. I included this in here because to me, circumference is just another name for perimeter. So when you're talking about circumference of a circle, you're talking about all the way around, or the perimeter of a circle. And when I talk about area of a circle, I'm talking about everything inside. Here's the center of the circle. Remember, the diameter goes from one edge to the other through the center, and the radius goes from the center to the edge. So radius plus radius is equal to the diameter. Our diameter divided by 2 is the radius. I do not like this approximation for pi. You have a pi button on Desmos and a pi button on your calculator, so be sure to use that instead. Formula for circumference of a circle is pi d, or 2 pi r. Area of a circle is pi r squared. So go ahead and work on the perimeter and area parts of big ideas in the worksheets. Have fun doing them, and I'll see you again next time.